Hi, this is Kenneth Wong, Senior Editor for DE 24/7, reporting from OzenCon at the Computer History Museum in Mountain View, California. The opening talk is by Dr. Prith Banarjee, CTO of Ansys. The emphasis of his talk is about the impact of AI programs like ChatGPT and the use of AI or machine learning as a pillar of the company's strategy going forward. We caught up with him to learn more.
During my presentation, I talked about the use of AI/ML to do sort of two things. One is to improve the customer productivity, the ease of use of the tools, and the other one was augmented simulation, how to speed things up through AI/ML. ChatGPT will not be used to accelerate things. That is what I talked about in our work, or the top-down methods and bottom-up methods. But ChatGPT will completely transform the way simulation tools are used in the future. Today, when you use a simulation tool such as HFSS for electromagnetic simulation or Fluent for fluid simulation, a user has to set like 100 different parameters, and you have to almost have to have a PhD in aerospace engineering to know which parameters to set. With the technology such as ChatGPT, in the future you can actually say, hey, Fluent, run a external aerodynamic simulation over a Boeing 747 plane, and it will figure out for that particular case what are the Fluent settings to use and automatically set it. That could be absolutely huge for the user. Now, this is not available today, but it's something that can be done in the future. The other one is as our customers, we have a lot of customers that use a lot of our Ansys tools, and they all ask questions of our engineers, our field application engineers. Imagine that how ChatGPT can actually look through all the interactions between the customer and the user, customer and the tool, customer and the engineer, and so on, and essentially create this treasure trove of information. So next time a customer asks a question that was probably asked before hundreds of times, so the ACE engineer, this field application engineer at Ansys, would be a super duper person, essentially becoming the first level of support. And this is something we are already working on at Ansys. In my overview presentation, I talked about 5 technology pillars of Ansys. One of those pillars is digital engineering. What is digital engineering? It's using technologies such as digital twins, model-based systems engineering, and so on, that are integrated with the simulation. Today, our core simulation solvers all use some form of finite element method, finite volume method, whatever, to solve simulation problems very, very accurately. Yes, it is very accurate, but it takes a long time to solve, right? And these problems have maybe 200 million unknowns, a billion unknowns, and so on. With reduced order models, you can take a problem with a billion unknowns and automatically reduce it to maybe 1,000 unknowns. And we have at Ansys a suite of technologies. We have static ROMs, dynamic ROMs, linear ROMs, non-linear ROMs, and those technologies are actually built into one of our standard tools called the Twin Builder, which is our digital twin tool. So that is already coming in. But our customers are also asking questions about uncertainty quantification, as you said. And so in the future, we will have, as part of digital engineering, we'll have reduced order models, uncertainty quantification, and all these model-based systems engineering tools that will sort of automatically go from the system level simulation to the 3D level simulations.
With AI workloads, the GPU plays a crucial role, so we also spoke to NVIDIA to get a better understanding.
So he is mainly excited about physics-informed neural network, which converge physics and machine learning into the model. So you train a model with the data and with physics laws like energy conservation or mass conservation law. So to do that, the user needs to train the model, the neural network, and do the inference. A lot of those workloads are accelerated by NVIDIA GPU. So they will need to upgrade their hardware to NVIDIA GPU to do the training and inference. So there are 2 categories of GPUs, right? First is compute. Those are suitable for data center usage. Mainly the workload is very big, the model is very big, the training data set is very big. the inference time requirement is very small, is very low. You have to inference very fast. The other category of our card is a workstation or desktop GPUs. Those are less powerful than the compute cards. They can do some simple, less demanding training and inference. So
one of Ansys' designer-friendly product is Ansys Discovery. Now let's see how the GPU affects its performance.
CPU is good at to do complex work in series. The GPU is good at breaking down the problem into smaller, simpler tasks and do them in parallel, right? So in that way, GPU can greatly accelerate the simulations, right? There's a design one, and you can immediately see the results when you change the design two. It's a real time, instant. You don't have to wait or anything. You can compare different models. You see because of fidelity difference, the RAM differences, the use of the memory of the GPU card, you can see them, and then you can do more dedicated simulations in Fluent. This is now Fluent. Or you can do, this is a 20 million cell aerodynamics model. You can really see do the simulations here in the Fluent as well. And it did this 100 iterations in 2 minutes and 5 times faster than the dual socket CPU. Yeah.
GPU-powered machines usually come from NVIDIA's hardware partners like Dell. So here is Dell on the kind of workstations you should use for AI-related workflow.
Well, for AI and ML, there's a lot of demands, especially on the GPU, as well as memory and other parts of your system. And so our more modern workstations are actually designed to meet the needs of that industry. And in fact, we created a specific product called the Data Science Workstation. And this is one of our higher-end tower workstations that allows you to configure it to your needs. So you can scale it to either a single GPU that you might use for inference-related stuff, or multiple GPUs that would be more typically when you're doing training exercises, because that puts a large demand on the system. So we have certified that with NVIDIA graphics cards, so a customer can get that pre-configured and pre-installed so they can get up and running, in a matter of minutes. Because many of our workstations are really very similar to our server products. Now, what we see practically when people are developing AI-related applications is most of the developers will use workstations because it gives them a lot of flexibility. They can manage them themselves. And then after they create their final application and they're going to deploy it, then they'll typically move to a server-based architecture because that's going to be in a data center and it has lights out management. So you can guarantee a certain level of uptime, that would be, more typical in an industrial application. Like, let's say you're going to do video surveillance work. You want to make sure, that system is running 24/7, 365, right? And so that's more something that you would do in the server environment. But a lot of the development work, the initial training is done on a workstation.
For more on simulation and design technologies, visit DE247 at digitalengineering247.com. Until next time, I'm Kenneth Wong, wishing you happy engineering.